So pip install NLTK. It's installed or it's installing? After installing this, import NLTK and NLTK dot download. Now this will open a browser window in the back.
And then EHU.
So a browser window open in the back, NLTK download like this. Click on download all. Natural language processing, text data. So NLTK.download will open a browser window in the back. Click on the browser window and then download all. Okay, once you have downloaded, it will store like this. True.
Sir, got error that a connection attempt failed because of the connectivity party did not properly respond after the period of time.
Just try again, NLTK.download. Server, that you are not able to connect to the server. After that, pip install text block. So we have to so these are the 3 libraries which need to be installed. Once I've imported all, please confirm. So within the natural language processing, the primary data is text, which is unsupervised learning. So text comes under unsupervised learning, text mining, speech, voice to text, speech translation, chatbots, etc. are all part of natural language processing. Now, this is one of the most important field in data science because 70% of the content on World Wide Web is text. 75% content on internet is text, 20% is images, and around 10% is streaming or videos or other types of content. One point of time it is 90% text. Now it came down to 70, but over a period of time it might go up to 50% as the images increase. So as of now, text is the largest component of World Wide Web or internet. So text is the thing. Now apart from that, text is also found in Word documents, PDF files, images, web pages. So the biggest challenge is pre-processing the text. The biggest challenge is the pre-processing of the text. Text has a lot of what we call special characters, emojis, white spaces, punctuations. All those things will have to be cleaned up. So pre-processing is a big challenge in things. So like cleaning punctuations, special characters, white spaces, emojis, etc. So a lot of things will be there in text which need to be cleaning. The pre-processing of text has direct impact on model building. So pre-processing of the text has a direct impact. So if you don't do the pre-processing properly, you will have problem in terms of building the models, either machine learning or deep learning models. Today, we will do web scraping. So we will scrape content from web page and pre-process and analyze the text. So we are going to do web scraping today. Okay. Refresh. Click on refresh. Install. Pip install exclamation pip install NLTK. Pip install text blob. Pip install word cloud. These libraries have to be installed separately.
We have to click on shift enter.
Yeah, you have to type this only, not the exclamation mark. Sorry, not the hashtag.
All the three attended we can do.
Separately.
So if once it is done, then accelerate.
Yeah. Then you have to do the other one because you can do all three, but we will not know which library is generating the error.
The down we are getting like already satisfied.
So it has to change the number. The star has to change to number. On the left side of the cell, you see the number. If the number is coming in, the installation is complete.
Yeah, mark it.
So no problem. Then you can install the other ones. Thank you, Santi. Oh, no need. You have already done it, right? Now import the normal libraries, pandas and all. It's okay, no problem.
సరే ఇప్పుడు పైన పిప్ ఇన్స్టాల్ 3 చేసినాక డైరెక్ట్ గా ఇంపోర్ట్ ఎన్ఎల్టీకే అవసరం లేదు.
ఇది చేయాలి, ఇంపోర్ట్ అనలిటిక్ అండ్ అనలిటిక్ డౌన్లోడ్ ఇవ్వకూడదు.
I do on time చేసేసుకో. ఇంపోర్ట్ ఎన్ఎల్టీకే ఎన్ఎల్టీకే డౌన్లోడ్ చేసి ఇన్స్టాల్ అవుతుంది. ఒక వెబ్సైట్ ఓపెన్ అవుతుంది. ఇంపోర్ట్ సరే ఎన్ఎల్టీకే డౌన్లోడ్ చేయాలి. షిఫ్ట్ అంటే కొట్టారు. బ్రౌజర్ లో డౌన్లోడ్ చేయాలి. కింద డెస్క్టాప్ బాగుందంటే డౌన్లోడ్ వచ్చిన అవుట్పుట్ ఆఫ్ స్కోర్ వచ్చి బాగుందంటే డౌన్లోడ్ రాడా ఎలా ఉండడానికి నన్నంటే మా దగ్గర ముందు సెలవు ఛార్జెస్ ఈవెన్ నైట్ దివాళీ అన్ని
Download our we will put brackets next to download. No problem. Okay, it's still running, okay? Close it. Green means all I need install. You got it. So Wikipedia COVID-19 page. We'll scrape the Wikipedia COVID-19 page. All right, we'll continue. So we are scraping the content of the web page of COVID-19 from Wikipedia. So COVID is equal to beautiful soup wiki dot wiki dot content comma LXML. Now LXML is the HTML type used by Wikipedia. It is a open source format, LXML, HTML, HTML5, HTML-lib, all these are open source formats which are there for creating web pages. So Wikipedia is using LXML format, which is an open source format. So COVID is equal to COVID dot get text script is equal to true. This is the content we get. Only the content, because in Wikipedia pages you have images and all, no? You have a lot of images and hyperlinks and all those things will be there. So basically, most of it is removed and we get the content which is not clean as of now. We have to still clean it. Beautiful soup is a function within the beautiful library is the library that extracts content from HTML pages. So beautiful BS4 is the library name. Actually, it is beautiful soup 4 version. So beautiful soup is the function name to extract content from a HTML page. Because in HTML page, you have a lot of things, images, headers, what you call hyperlinks, chat windows, all those things will be there. But we don't want all of those things. We want the content of the web page. That too, we want only text content. When you import the libraries, pandas, numpy, matplotlib, and this, and then you can import the request and BS4 for getting the content. So if you see our content output, there are a lot of things to be cleaned. So we have to remove punctuations, special characters, square brackets or round brackets, digits. Sometimes we have to remove the digits also. Emojis. Then stop words. So stop words is a and is the etc., which are of no use for our analysis. Stop words. Even hyperlinks, hyper or HTML links. Etc. Then we have to convert the text to lower case. You have to convert the text to lower case, all small letters. Then we have to do normalization of words. Which is either lemmatization or stemming. So what this process is, let us say you have wants, wanted, wanting, The root word for this is want. So this process we call it as normalization or normalization, where we get the root word. Then we also use lexicons. Lexicons are predefined list of words that are used for comparison. Like negative words lexicon is a list of all negative words. So lexicons are there which are developed by natural language researchers, like list of positive words, list of negative words, list of neutral words. All these words are created by language researchers, and these lists are, we call them as lexicons. So these lists are used for comparison. If you want to compare what type of words are there in your content, positive words, negative words, or neutral words, we need to have this lexicon. So by comparing these words in the lexicon to your words, we can do the sentiment analysis. If more positive words are there, positive sentiment. If more negative words are there, then it is given a negative sentiment. So for cleaning purposes, we have to use the inbuilt library import RE, regular expressions library. First, we will replace square bracket with numbers, which is the footnotes. Footnote reference numbers, space. COVID is equal to COVID, sorry, RE dot sub, open bracket, R, single quote, slash, square bracket slash, D plus, slash, close single quotes, comma, double quotes, comma, sorry. So if I run COVID, see all the square bracket things are gone. right? Similarly, we have some things in round brackets. Do we have anything in square brackets text? Square bracket text is not there. I think we have round brackets only, text and numbers. Yeah. Is equal to V sub. You can copy this from top. Instead of D plus, make it W plus. D plus is digits, W plus is words. D plus is digits, W plus is words. And also have to change the brackets, right? Your capital words also. Capital W plus. Okay. Now we have to do something called tokenization. One type of tokenization is sentence tokenization, where breaking content into sentences with delimiter being full stop. Word tokenization is breaking content into words, or also called as tokens, with delimiter space. So we have to do two tokenization, either sentence tokenization has to be done or word tokenization. So sentence tokenization is used for sentiment analysis. Word tokenization is used for analyzing text. Okay. From NLTK dot tokenize import sent underscore tokenize. So sent underscore tokenize is a very important function as part of the NLTK library. So sent tokenize will break it into sentences. Sentences is equal to sent tokenize COVID. Length sentences. 1008 sentences are there. So it broke the content into 1008 sentences. Full stop based sentences. Hello. Yeah, hello. Yes. I think everything is done. It's done. It is done. It's done. Yeah. Everything is done. Yeah. Screenshot of what? Okay. Okay. Hmm. Hello. Okay. Now, text block based sentiment analysis generates two metrics. So text block is a library that we use it for sentiment analysis. First one is the polarity score is a float between -1 and 1. Polarity score is calculated based on positive or negative words lexicon comparison. The other metric which it calculates is subjectivity is a score between 0 and 1. Closer to 1 indicates high personal opinion. Without factual information. And low, closer to 0, indicates low personal opinion with factual information. With factual information. So text block is a library that is used in sentiment analysis. NLTK also has sentiment analysis part, but the problem is NLTK sentiment is not that good compared to text block. Text block has good sentiment analysis. There is one more library called Spacey, which is also widely used in text mining, large scale text mining, that also has sentiment analysis. Compared to these three libraries, text block is the best sentiment analysis. From text block, import text block. So sentence one is equal to text block. Pelé is the greatest football player. There is a sentiment. S1 dot sentiment. So polarity 1, subjectivity 1. This is highly positive sentence and it is purely highly personal opinion without any factual information. So to this, who scored more than 1,000 goals? Now, so I added more than 1,000 goals. Look at subjectivity, it fell down to 0.75. We have given some factual information. And it is also positive statement which came down to 0.75. Good positive statement with subjectivity also less than 1. Because 1 means it's personal opinion. Here we are giving factual information. Why is the greatest player? Because he scored more than 1,000 goals. So the more factual information you give, the more the subjectivity will be closer to 0. So S1 is equal to text block and then you type the sentence. Similarly, if you say S2, climate change threatens the survival of humanity. So S2 dot sentiment, see, polarity is 0, subjectivity is also 0. Due to rise in global temperatures. So I have to put it in one sentence. Now you see, polarity is negative. That means it's a negative sentiment. And subjectivity is also see close to 0 because due to rise in global temperatures. Earlier it was both 0. Now see how the score is altered by providing a factual information. By providing factual information, the subjectivity will come to 0, closer to 0. If you don't provide any factual information, it will be closer to 1. So text block sentiment analysis is widely used. It has good accuracy and good understanding of the context of the sentences. All right. Now let us create a function def analyze underscore sentiment text colon analysis is equal to text block of text if analysis dot sentiment dot polarity greater than 1 colon return positive if analysis dot sentiment dot polarity double equals to 0 colon return neutral else colon return negative. So this is a simple function which we are creating to analyze the sentiment of sentences based on polarity. All right. So now we have to convert our sentences to DF. Sentences is equal to PD dot data frame sentences DF is equal to PD dot data frame sentences. Sentences DF dot columns is equal to sentences. So we are adding the name of column to the data frame. So sentences DF square bracket single quote sentiment. We are adding a new column called sentiment is equal to square bracket str analyze underscore sentiment of x for x in sentences df dot sentences. So we converted sentences into a data frame. Then we are using the analyze sentiment function to calculate the sentiment. So sentences df dot sentences dot value counts. Oh, what happened? Oh, sentiment. Neutral 688, negative 320. Why we got only two? No positive sentiments, huh? Okay, greater than zero, sorry. Hey, this is not greater than one, this is greater than zero. In that analyze sentiment, I gave it as greater than one. Let's say we didn't get positive sentiments. Greater than zero. Polarity greater than zero, positive. Equal to zero, neutral. Else negative. Where Polarity double single element. Now you can see here, neutral are 688, positive 244, negative 76. These are the sentiments for the 1008 sentences we have in our data. All right. Got it? All of the sentiment analysis. Now, from NLTK dot tokenize, import word tokenize. You're getting error, huh? Sir, good afternoon అండి. డాన్ చెప్పండి. అవును. ట్యూస్డే కుదరదు. థర్స్డే కూడా కుదరదు. థర్స్డే మార్నింగ్ ఇక్కడే ఉంది. ఫ్రైడే ఆఫ్టర్నూన్ చూసుకుంటా. థర్స్డే ఆఫ్టర్నూన్ పెట్టు. Then so word tokenize. COVID words is equal to word tokenize COVID words. Sorry, COVID. So COVID words is equal to square bracket W for W in COVID words if W dot is all num. From NLTK dot corpus import stop words. Stop underscore words is equal to set stop words dot words English. COVID words is equal to square bracket W for W in COVID words if not str dot lower W in stop underscore words. COVID words is equal to square bracket W dot lower for W in COVID words. So we have broken the words, then we have taken only alphanumeric words. Then using the stop words, we are removing the words which are not relevant. E is A and D. Then we convert everything to lowercase. And we are taking into corpus only those words whose frequency is greater than 2. So basically we are removing the words which are coming only once in our data. So that way we can reduce the size of the corpus. So our data is in data frame, right? That means it has to run loop. Each row is different. Our data is not in a single list. It's in a row-wise list. So W for W means it has to iterate over each row of the data frame. Had the data been in a single list, then we can directly write the function dot lower or dot like that. But here our data is in rows, 1008 rows. So each row it has to go through. So that is why we are using the loops. Oh, it's an empty. Empty list, huh? Oh, here we have to give COVID words. So it is an empty list. Now you can see the words. Oh, we got digits. Twenty 2019 we got. So after the where we have done the RE subs and then add the digits removal cell and run all the cells. So that we don't get the digits in our data. Cell run all cells. It will also run the download, close the download. So you can see the most common words, right? And their frequencies. Most common words and their frequencies. Now let us build a word cloud. From word cloud, import word cloud. COVID underscore words. We are creating a single list. Dot join COVID words. Word cloud is equal to word cloud COVID underscore words, comma, width is equal to 1000, comma, height is equal to 500. Oh, sorry. Dot generate COVID underscore words. ULP dot figure. Yeah, pip install. Yeah. Pip install. Exclamation pip install WordPress. It's a small library. Okay, got it? So based on the frequency of the word, the size of the font size of the word will be decided. So the most frequent the word is occurring, the larger the word size. Okay, this is the word cloud, which also tells us there are no unnecessary what you call words or special characters and all. So word cloud will also tell us whether there are any pre-processing related to be done further, like any special characters or numbers, something like that. Whether they have to be done or not, that also you can find out using this word cloud. Now, post pre-processing, text must be converted into numbers, specifically matrices, of numbers, because we can't do anything with text, right? Text need to be converted to numbers, a matrix of numbers. Then only we can do some sort of model building or analysis. Simply on words, we can't do anything. There are algorithms available that do on words also, but they also use the matrices as input. One is term document matrix, or also called as term document or sentence matrix. Term document or sentence matrix, where terms or words are in rows and document or sentences in columns. So terms of words in the rows, documents or sentences in columns, and the counts will be the values or numbers in the matrix. The transpose of the above one is document or sentence term matrix, where terms or words are in columns and documents or sentences in rows. So term document matrix and document term matrix. So term document matrix, also called as TDM. This we call it as document term matrix, or also called as DTM. Both matrices are sparse matrices. Sparse matrices means many zeros will be there. Many zeros in matrix. Both the matrices will be sparse matrices. So if you are looking at the what do you mean by DTM versus TDM? So here tweet is or document. Tweet or document is same. Tweet or document or sentence and the words. Tweet or document or sentiment. Tweet, document or sentiment, and then the terms. So this is how the matrix will be created. Okay. From sklearn dot feature extraction dot text import count vectorizer. Vectorizer is equal to count vectorizer So within count vectorizers, you can give lot of options. So when you look at count vectorizer function, so you can give lowercase is equal to true. That means it will convert everybody into smaller letters. Preprocessor, if you want anything, you can give. Tokenizer, also you can give. Stop words, English. If you want, we can use stop words, English. And then analyzer is word. So max features, this is very important. Max features means how many columns we want. So we have 10,000 rows, right? Sorry, 1,000 rows. So for 1,000 rows, I think we can go with 20 variables. 20 into 50, right? So max underscore features is equal to 20. So if it is a larger corpus, we can give larger amount of variables. X is equal to count vectorizer dot fit underscore transform COVID words. I think the length of COVID words is very long, sir. We forgot the length of COVID words. Length of COVID words 13,788. So we can give more. So we can say 200. Okay. We can give 200 thing. So X dot shape is 13,788 rows, 200 variables. 13,788 rows, 200 variables. So by default, count vectorizer will give you document term matrix. It will give you the document term matrix. So if you transpose this, it will become term document matrix. If you transpose this matrix, it will become term document matrix. So PD dot data frame X dot true array, comma, columns is equal to vectorizer dot vocabulary underscore dot head 10. So you can see the words. I think there are no here. We'll see tail. Tail sometimes will be the words. Numbers will be there. So we see lot of but anyway, this is the document term matrix. You take 20. So we get any, well, let's see, yeah, here you see the one coming up. So this is how you can see the document term matrix. Each column. Only one will be there in any of the. Any one of the values where it will be there. Okay, so once you convert this into document term matrix, we can do modeling. We can do modeling. Okay. So this is the process of creating a count vectorizer. Now we have 1008 sentences, right? We have 1008 sentences. So 1008 sentences means 20 variables we can do. Okay. So vectorizer can be run on sentences. So let us say we will add one more features, so like vectorizer min underscore df is equal to 5, n-gram range is equal to 2 comma 2. So what happened? Okay. So this is now for us, we have to create a new vectorizer. Vectorizer 2 is equal to count vectorizer max underscore feature equal to 20, min underscore df is equal to 5, comma n-gram range is equal to 2 bigrams. That means combination of two words. Combination of two words. X underscore vect is equal to vectorizer 2 dot fit underscore transform sentences df dot sentences x underscore vec dot shape. So we have 1259 sentences, 20 variables. 1259 sentences are there. So I think we can go for more. 1259 means $25. PD dot data frame x underscore vec dot to array comma columns is equal to vectorizer 2 dot vocabulary dot head. Oh, we have stop words. We also have to get stop words. Stop underscore words is equal to stop underscore words. Now we don't get the stop words, right? So 25 variables, bigrams, two words, and stop words. We are removing the stop words also because we didn't remove stop words on the sentences, right? We are removing it here. I'm sorry. Just checking whether there is any mistake. Yeah. So this is the vectorizer 2, which we have created. Tomorrow you'll come class or it will be online? I'll come. So we'll come class. 9 o'clock, 9 to 1. Okay. So we have created the now. Y is equal to sentences df dot sentiment. Our y is sentiment df dot sentiment. From sklearn dot preprocessing import label encoder. Y is equal to label encoder dot fit underscore transform of y. We are label encoding y, which is in positive, negative, and neutral, right? So we are label encoding our dependent variable, which is sentiment, positive, negative, and neutral. Hmm. Did you give underscore after vocabulary? Vector 2? Okay. From sklearn dot linear model, import logistic regression. Logit is equal to logistic regression multi underscore class is equal to multinomial. Eighty-one point 17 accuracy. Okay. Logit predict is equal to logit model dot predict x underscore vect. PD dot crosstab y comma logit predict. So why you got only 1, 2 predictions? What happened to 0? Okay, it is not able to predict 0, 1, 2. The logistic regression is failed to predict 0 class. It is giving only 1 and 2 predictions. So logistic regression, even if you give multi-class is equal to multinomial, it is not able to predict. Why it is not predicting logistic regression, multinomial, multi-class classification. Multinomial solver we have to change LBFGS. Solver is equal to LBFGS. No, still it is not giving. It is somehow not predicting. So we'll go to decision tree. So all of you ran the logistic regression model. Yeah. All right. So it's not able to predict the zero class. Sklearn dot tree import decision tree classifier. Tree is equal to decision tree classifier. Tree model is equal to tree dot fit x underscore vet comma y. Model dot score x underscore vet comma y. 82.12. Tree predict is equal to tree model dot predict x underscore vet. PD dot crosstab y comma tree predict. Yeah, this is predicting correctly. So it is predicting zero class wrong. 6. These are the correct predictions. Diagonal are correct predictions. Rest of all are wrong predictions. Diagonal are correct predictions. Rest of all are wrong predictions. All right. So you can try other models also. Random forest classifier, GB classifiers and all. Dot ensemble. 82.12. Same thing what we got in decision tree, we are getting for random forest. RF credit is equal to RF model dot credit X underscore what? PD dot cluster Y comma RF credit. Similar metrics for decision tree and random forest. $80.93 by best. Possibility. No. Categorical NP only. So neighbors 80.93 categorical neighbors. on SQL dot ensemble import gradient boosting classifier. GVM is equal to gradient boosting classifier n underscore estimators 3000 GVM model is equal to GVM dot get x underscore vet comma y. X underscore vet comma y. 82.12. Same like decision tree. All right. So we'll stop it here and we'll continue in tomorrow's session. Tree-based models were getting the same score because its data is very small. Random forest and boosting machine need lot of data, right? Because of the smallness of data, we are getting the same score. Okay, save the send to the files.